The pituitary gland, often referred to as the master gland, plays a pivotal role in regulating various bodily functions through its influence on other endocrine glands. Beyond its well-known functions in growth, metabolism, and reproduction, recent research has highlighted its significant impact on emotional regulation and psychological well-being. Here explores the intricate relationship between the pituitary gland and emotions, drawing on professional studies and detailed findings. One of the most critical pathways linking the pituitary gland to emotions is the hypothalamic pituitary adrenal axis, called HPA. This neuroendocrine system is activated in response to stress and plays a crucial role in regulating mood and behavior. The HPA axis involves a complex interaction between the hypothalamus pituitary gland and adrenal gland. When an individual experiences stress, the hypothalamus releases corticotropin, releasing hormone which stimulates the pituitary gland to secrete adrenocorticotropic hormone called ACTH. In turn, ACTH prompts the adrenal glands to produce cortisol, a hormone associated with the body's stress response. Studies have shown that dysregulation of the HPA axis can lead to heightened stress levels and alterations in emotional state. For instance, individuals with anxiety disorders often exhibit an overactive HPA axis, resulting in excessive cortisol production and heightened emotional reactivity. Conversely, disruptions in the HPA axis have also been linked to depressive disorders, where reduced cortisol levels and impaired feedback mechanisms contribute to persistent low mood and anhedonia. Neuroimaging studies have provided valuable insights into the structural and functional changes in the pituitary gland associated with psychiatric disorders. Magnetic resonance imaging has revealed volumetric alterations in the pituitary gland in individuals with schizophrenia, mood disorders, anxiety disorders, and somatoform disorders. These changes are thought to reflect the gland in its role in regulating hormones that influence emotional and cognitive functions. For example, research has shown that individuals with major depressive disorder often exhibit reduced pituitary volume, which may contribute to the dysregulation of the HPA axis and the persistence of depressive symptoms. Similarly, studies on schizophrenia have identified structural abnormalities in the pituitary gland, suggesting a potential link between pituitary dysfunction and the emotional and cognitive deficits observed in this disorder. Hormonal influence on emotions. The pituitary gland secretes several hormones that directly impact emotions and behavior. Adrenaline released in response to stress triggers the fight or flight response, preparing the body to react to perceived threats almost instantly. Other hormones such as oxytocin and vasopressin play a role in social bonding and emotional regulation. Oxytocin, often referred to as the love hormone, is involved in feelings of trust, empathy, and attachment, while vasopressin is associated with social behaviors and stress resilience. Research has shown that oxytocin administration can enhance social cognition and reduce anxiety, highlighting its potential therapeutic applications in emotional disorders. Similarly, vasopressin has been implicated in the regulation of social behaviors and stress responses, suggesting that targeting these hormones could offer new avenues for treating emotional and psychiatric conditions. In addition to its long-term effects on mood and behavior, the pituitary gland can also influence instant emotional responses. The release of adrenaline by the adrenal glands triggered by the pituitary secretion of ACTH can lead to immediate feelings of fear, anxiety, or excitement as part of the fight or flight response. Additionally, the rapid release of oxytocin and vasopressin can quickly affect social bonding and emotional regulation, creating instant feelings of trust, attachment, or social stress together the pituitary gland. These influence on emotions is a complex and multifaceted process involving the regulation of hormones, the HPA axis, and interactions with other brain regions. Professional research has shed light on the significant role this gland plays in emotional regulation and the development of psychiatric disorders. Understanding these mechanisms can pave the way for novel therapeutic interventions targeting the pituitary gland and its associated pathways, offering hope for individuals struggling with emotional and psychological challenges. Moreover, the pituitary gland, its ability to affect instant emotional responses underscores its critical role in both immediate and long-term emotional health.